Design, Creativity and Technology channel. My name's Aaron. G'day and welcome back. Today on the channel I'm making this ratchet pawl. Now this part goes into one of our projects at the TAFE college, which is a large winch project. And the purpose for the ratchet pawl obviously is so the winch, as you wind it up, the ratchet locks into specific places and holds the winch from unwinding. Now it's an easy part, it's just a little 2D part. However, the challenge here today is holding it and machining it. So let's take a look at how I did that today. So you can see here that I've basically made up a simple bit of steel plate that was laying around the workshop, drilled a hole in it, drilled and reamed a hole for the dowel pin, and tapped a thread for the cap head bolt so it will hold it. Now the dowel pin is predominantly there for one reason and one reason only. The dowel pin is a registry point, so each time we put a part in, the apprentice will actually align it in the correct orientation. But for work holding, obviously we're relying on the bolt to hold the part down. This is my fixture. Now it's a very simple fixture that I've created. It has a dowel pin there and a threaded hole. And here is our ratchet pawl that we're trying to make today. So to load the part today, we pick it up here, pop it in, tighten up the bolt. Now as I tighten it, I've got to forcefully hold it into that dowel pin while I crank up on that with my Allen key. So here is our Haas Mini Mill 2 table, and I've modelled it with the rotary in place so you can see, and the part is in the vise and how to set it up. Now in here we can see we've got our parallels and everything. Let's just turn the colour coding on so you can see it. We've got our parallels in there holding the part up above the vise. Turn that off, and this way here you can clearly see that you'll need parallel strips of about 40mm high. The part in here. Now in actual fact we'll put that part in the center of the vise where the clamping pressure is the strongest. We won't keep it to one side. You can see here that we've picked our work coordinate system here to be the center of that bolt, and Z0 will be top of the part, and XY is obviously the center of that hole. Okay, and here we want a single surface probe. Enter. And arrow down we want Z axis only. Enter. And down here in the next line we're just going to go down -10. Alright, I can just go touchscreen here and go run an MDI, and I'll activate the probe. Right, so let's probe this round boss. Now we're not after a super accurate part, we are going to probe a cap head bolt, but what is it? It's a ratchet pawl. It's not requiring accuracy at all, right? Otherwise I wouldn't probe a cap head bolt. Alright, and you'll see here that we are probing G58. Cycle start. The wireless probe will start talking to the probe, and away we go. So let's simulate that now. We're going to be dropping in here with our end mill. I think I'm using an 8mm Sutton Tools Harmony end mill here to machine this with a BT40 collet holder. So we're going to eat away at the right hand side here. Now you'll notice I've set my top height fairly high, and the reason I've done that is so when we're doing rapid moves and travelling over that bolt or that cap head bolt there, we don't smash the cutter in it. Now the cutter will now step over to the left hand side and do some 2D adaptive clearing on the opposite side. So you'll notice this is a separate tool path to the other one, so that way I can contain the tool paths so they don't flow over into one another. You'll notice here it is lifting up to 20mm, positive 20. So now I've tightened that bolt up now, and as you can see it sticks up quite a bit, so you have to adjust your height in Fusion 360 so you don't crash into that every time you step up and do a rapid move, so that's safe travelling height. And I've stepped mine up quite a little bit here. So let's shut the door. Now, I can only shoot through the door today, so I'll try to run this without coolant, and we'll see. Hopefully I don't break an end mill. So to run the Haas here today, we've got to make sure we're in memory mode. I like to have position on and have all these up and showing. So I've got my distance to go, my operator machine, and my G58. So I've called up G58 here in the program. So we'll cycle start. Now I'll just put it on slow rapids at the start. So I've got the rapids down here at the moment, 25%. Now I may have to give the coolant a little bit of a tickle now and then so we don't blow that end mill. Now this here is a coated end mill from Sutton Tools, designed for steel. It's off their Harmony range. I've had good success with them. As you know, at home I run all my end mills from Live Tools from Arthur up there in Newcastle, but here at the college we're running Sutton Tools. They're one of our industry partners. We've got a nice little blue chip coming off there. You'll watch it step up now and and go to the other side. Sort of really a little bit close to that dowel pin, but we've got plenty of room. Might just give it a courtesy flush. Don't like doing that as you shock the carbide. So now we're going to drop in and do a 2D contour and contain it just around that perimeter. You'll notice there that it does get very close to that dowel pin. Very, very close. We can zoom in here a little bit and take a look at it. So there's a little bit of pucker factor going on there when I first did this. But look, in hindsight, we've got lots of distance away from that. So we've probably got about a 5mm gap there before I hit that. And that is a 6mm dowel pin. Well, that concludes today's video. I hope you got something out of it, and I hope you enjoyed watching it. Feel free to leave me a comment below, and as always, like and subscribe. I'd really appreciate it. Have a lovely day. Bye for now.